They knew all the answers. So if you guys could draw pictures of what you consider the visual of the discontinuities. So Milo and Ben, the whiteboard is in between, under the seat between the two of you, and Milo, the pen is under you. So it's like, I just can't piece out past period.
Thank you.
Oh, no, that's horizontal. Oh my
Yeah.
god.
It's all a perspective.
Yeah. If I was looking at it like this.
No, it could be correct. It's all orientation.
Every other point. Like even,
Are you being taught like this? Can you like that? Like arrows.
Oh, right.
Oh, that's yeah, fair enough.
is there some at this point?
Right, yeah.
No, there's nothing at, there's nothing to slow.
Okay, so pictures.
We're going to slow approaching.
I see.
Here, we're going. Well, no.
Saw those two. People have various forms of this kind of picture. Okay. So I don't see a lot of different, like some of you have different forms of these. Okay, so there's one other, but corners. Can't do a derivative at a corner. Vertical tangents, some of you had it drawn within a curve, so you can't do a derivative at a vertical tangent or a vertical line. You can't do derivatives at discontinuities, which there were lots of versions of that you guys drew.
Wait, can you do a derivative at, oh, not at a whole discontinuity?
Oh, what's the?
No discontinuities. And then the last flavor, curvy corners. They are called cusps. So we're going to look at examples of these in a second. But here's the visual of that one, which you guys can't see very well, but it's a picture of the corner of a room, and there's a molar called a bicuspid, cusp. And then there's discontinuities, the jump discontinuity and an infinite discontinuity. They didn't draw removable, but that's also not allowed. And then they didn't take a picture of a tan dude standing. They took a picture of a tan person laying down on the beach, and then they turned him upside down. So vertical tan gentleman. You cannot have this. You can't do derivative at a vertical tangent. Tangent. Okay, so we will look at each of these.
That's really like this.
And first period was not impressed with the cocoa bean corn. I don't know why. I did show you guys this, right? I didn't show you this? Oh my goodness. Product rule. Because who wouldn't make a product out of cocoa beans and corn, right? So, with product rule, cocoa beans and a derivative of corn, which is Fritos. Derivative of corn, get it? It's made from corn. Plus corn and chocolate bar, because chocolate is made from a derivative of cocoa beans. Sounds horrible, but this is product rule. Get it? It's on the board all year. Cocoa bean Fritos and corn chocolate. Nom nom. Get it? Get it? Derivative? Always amuses me. Okay, so this will probably be pretty fast. All right. For like the 5th time. All right, we get the point. Can't do the derivative. Add a corner. The function is defined this way, and the derivative is -1 when x is bigger than 0, or +1 when x is bigger than 0, and -1 when x is less than 0. And looking at it from this side and that side, the slopes are different, can't do the derivative. That's what it's like to be at a corner. Doesn't have to be, it could be anything like that. It could be a straight line and a curve. Any like kink in the system, can't do the derivative. So corners are bad. There's an example. Curvy corners are also a problem. Lily, doing power rule, what is the derivative of this?
2/3 x to the -1/3.
She said -1/3, and I'm just going to write it down there. Felipe, pre-cal, when is this f prime function not defined?
That's here.
So at 0, yes, Andy.
Oh, I was just gonna ask, you said that at discontinuities, there's no slope, at a discontinuity where there's like,
Okay, we'll that's coming up. So this one, visually, it shows there's a curvy like whoop to it. But also analytically, Lily did the derivative, we looked at it. I cannot put 0 into this function, so the derivative doesn't exist there. So visually you can tell, analytically you can tell. Let's see, this one. Hello? What's the derivative of that? 1/3 what? The power is 1/3. So what is the derivative of that? Multiply by the power and lower the power. So multiplying by the power, it's 1/3. And now subtract 1 from the exponent.
X -2/3.
Okay, and visually this one's hard to see. I mean, sine and cosine, they have those little wiggles. Is it like steep enough to make it a vertical tangent? I don't know. But analytically, doing the derivative, that x moved to the denominator, it's also undefined at x equals 0. At a split second, there's a vertical tangent in there. Okay? And now, Andy, the next one is discontinuities. So right here, the slope from the left is 0, the slope from the right is 0. What's the problem? I can't put a tangent line down on there. Like, am I going to say, well, this is where it's colored in, so we're going to declare it's that side slope? What if they were both open? So if it's any kind of discontinuity at all, it's just not possible to do the slope there. just infinite discontinuity, jump discontinuity, removable, none of them. So there's a problem in the textbook that I replaced the textbook with Delta Math, and I'm not sure Delta Math is going to do this. But there is a problem in the textbook that they make the slopes come together and it looks all nice and pretty. However, it's not continuous at that coordinate. So they're like, ah, just kidding, got you. Hopefully you'll run into that on the Delta Math tonight. Okay, so show some work to show that this piecewise function is not differentiable at 0. See if you can figure out the work to show. And corn. Oops, sorry. So what would you show as work? First of all, okay, first of all, I'm going to check continuity. Limit from the left equals the limit from the right and equals the function at that point. Yep, it's continuous, so it could have a derivative, but does it? Evelyn, how do I show the derivative of this piecewise function? Like, how do I write it out? Is it going to be a single function, or is it also a piecewise?
It's also piecewise.
Okay. What's the top piece going to be?
And the bottom is just
And right here, I'm not going to put the equals in yet. I might add it later, but I'm not going to put it in yet. As I come at 0 from the left of this derivative, I get 0. So checking differentiability, 0 from the right. The slope was 4. The two slopes were different. So this is going out at something sharp. This came in as a nice smooth round curve. So slope of 0, slope of 4, that made this weird corner, curvy something, not differentiable at 0. Okay? Question? Yes?
So is that all you write? Like, would we have to like circle anything or? Yeah.
So it's not differentiable because the slopes from the different sides are different. And the question? Okay. Hello. All right. So now there's this thing called local linearity. That's this picture. There's the roller coaster, big metal tracks that are going curvy and stuff. But if you're an itty bitty teeny tiny ant on those railroad tracks, it's gonna just look flat. And I don't know why, but I always pick on Kansas. Have any of you driven across the country and had to drive through Kansas or Nebraska? Yeah, it's like, you'd swear the world is flat. You'd swear those flat earthers were right, because you see nothing but like corn, corn, corn. Ooh, wheat! Back to corn. As flat can be. So, here's the thing. Apologize to all those from Kansas. So this curve, it's a curve, right? Well, I'm an itty bitty teeny tiny bug, and my world is small. Does it look like it's a flat line now? So this is what local linearity means. It means you can put a tangent line even on curves, because you zoom in enough. You're a person in the middle of Kansas, in the middle of all that corn, you'd swear the earth is flat. Okay. Absolute value, that corner, does it ever look like that corner's gonna go away? No. It's staying, right? So, not locally linear, and as much as you're gonna zoom in, it's not gonna be straight. Okay, and because I have them, I will show you, like this looks like the absolute value, but the little buggers, they made it so it's smoothed out. So this one actually will eventually be fine. And then, as annoying as it is, then there's this one. It's a function. Looks fine, right? No issues, no issues. Oh my goodness, we put a wrinkle in it. Tee, first period was like, dude, you wouldn't do that. No, I can't. So lucky for you, I hang out on the Facebook page for AP Calculus teachers. This is the brainchild that this came from. Whenever he puts something out there, I'm like, oh Jesus, I gotta tell them about this. So he writes questions for the AP exam, and the things that he puts on Facebook are significantly harder than what you'd see. But I want you to expose you to the demented mind of Brian Passwater and Tony Record, so that you will see what evil can be, and getting in, like, to understand the beast, you must like get into the mind. So there's that. It looks fine from, now it's gone. Oh, it looks like your friendly cubic function, but it's not. Okay. So that's what it means to be locally linear, is if you zoom in a super, super duper lot, is it smooth? So, now, I want you guys to get out your calculator and see if you can use them. Do any of you have the TI-83? Everyone's got an 84? Does anyone have something not a TI-84? Like a Casio or an 89? Okay. I unfortunately have an 83. So let's see. Let's see if we can do the derivative of x squared at x equals 4. All right, yours is going to look so much nicer than mine, but derivative is under the math key, and it's not listed on here, so Pass number 7, oh, enderiv or ender. If you are looking at your textbook, anytime it says ender, it's asking you to use your calculator or Desmos to do this. So derivative, and then on yours, you'll see the D parentheses, type in the function. So I'm going to type in x squared, and then I need to say the derivative of x squared. I need to say the variable x next, and then where I want it to do the derivative at. Okay? And if I wanted the derivative at another thing, do you guys know how to pull up that same line again? If I hit the second key and enter, I'm like, you know what? I want the derivative at 1. It's a lot less typing. Okay. If you are on Desmos, so some of you are, on the AP exam, whenever you're allowed to use a calculator, they will make Desmos active so you can use it. You don't have to, but it's there. And there are different ways to do the derivative. Right now, I just renamed that complicated function f of x, so I just say f prime of x, and check that derivative out. Like, so cool. It made my day. Okay, let's see. There was another way to do this. d/dx, and then to say f of x? Yes. I'm not good with Desmos. I don't use it for this. But if you, yes?
So during the exam, are we allowed to bring our own graphing calculator?
Yep. So you can bring your own graphing calculator, and if you don't have one, or you don't like it, or you prefer Desmos, you can do it on Desmos.
So does that mean we're allowed to use it on the entire exam?
For the AP exam, no. There'll be sections where you can use it, and then that they have to go away. Let's see. Do you guys know how to do intersections of lines and stuff on Desmos? They're kind of a pain in on the graphing calculator, but on Desmos, here's the complicated way to do it. Point at it, point at it, point at it, and it tells you. And if you want the maximum, point at it. Minimum, point at it. Graphing calculator, much more tedious. So I will try to point out the calculator tricks as we go. I'm really good with the graphing calculator, but certain things I would do on this, other things I would do on the handheld. You are allowed to have both on the AP exam. You're allowed to bring your own handheld, and if your batteries die, if you are allowed to use a calculator, Desmos is there. And if I wanted, let's see, y prime, let's see if it'll let me do this, at 2. Nope.
Try dy.
Yeah, dy dx of y at 2, it's saying the slope is 0, so you can evaluate at a tiny little spot. Try and make Desmos, if you're on it, or your calculator, do the derivative of the absolute value at 0. Nope. Does it give you an answer or no?
Where are the absolute value bars?
On the calculator,
Yeah.
you need to do,
The It's in math.
No.
Math num. So if I want to do the derivative on it, I'm going to hit the math button, go to NUM, absolute values at the top one.
It gives me 0.
So telling the calculator it will do the derivative at 0. Here, depends on how we ask Desmos to do this. That I defined g of x to be absolute value and then said, find the slope at 0, it does tell me undefined. However, it took me a while in first period to figure out how to make it give me the right answer. Like in other formats, it was like, no, I'm not doing it. Because I was asking it, it evaluated the function first, got a constant, and then said the derivative of that constant is 0. So I didn't know how to manipulate Desmos well. So just trying to give you some exposure to these tools that you're allowed to use. And another thing for your calculators, first period, I noticed a lot of people changing the batteries recommended. Yeah, so if you hit the blue second key and the down arrow, second down, second down, second down, second down, it makes it dimmer and makes your batteries last a tiny bit longer. Or you could just turn it off. So some people had it so dark that the screen was almost black, and like you can't see your graph and you're burning up the battery. So second down turns it dimmer, second up makes it brighter. So you can stretch it a couple more minutes out of it on the AP exam or whatever if you're needing to. Okay. Let's see. And class is not over for a minute. Yeah. So if you guys want to start the Desmos, Delta Math, or if you have questions, let me know.